discrete and continuous. That's going to be our focus here to start off. And what we want to do is just kind of simplify the definition. Discrete for us is going to mean that we have individual points. Continuous, on the other hand, means that we have an infinite amount of points. That's the key right there. Discrete, individual, countable. Continuous, an infinite amount of them. Because what we're going to do is we're going to take a look at some of the graphs and how the graphs and some characteristics of the graphs of different functions and how we can actually classify them as either being discrete or continuous. So if we go ahead and jump over here to the other side here and look, we could see that we have individual points. It looks like I just plotted some of the actual points that make up the line. If that's the case, that's going to be something that represents a discrete relationship. However, whenever I connect all those points, now I have a well-connected line, arrows on both ends. That means I'm going to extend infinitely in both directions. If it's extending and we have an infinite amount of points, that's going to be continuous then. All right, so nothing too earth-shattering there, just making sure we keep them, separated one by one. The other thing is we have another visual that kind of re-references our vertical line test. And if you go back to the previous video, you would understand that the vertical line test is the test that we can use to see if a graph itself is or is not a function. And so here we have a parabola opening up, and if we could envision all the vertical lines that pass through that parabola would only intersect that at one point, so therefore it passes the vertical line test. However, if I take this shape and rotate it, now we see that we're failing the vertical line test. And we have multiple vertical lines that would cause it to fail, but as long as there's one, then it's no longer a function because it failed the vertical line test. All right, so let's kind of put all of these pieces of the puzzle into a bigger type of problem. So here we go. We're going to be asked to not only graph a given equation, all right, but we're going to have to determine the domain and range. We're going to have to determine whether the equation is a function to see if it's one-to-one, on-to, both or neither, and then state whether it's discrete or continuous. We've got a lot of stuff to do here. So let's go ahead and get started. First and foremost, we see that our equation is a linear equation. I have 1/2 x minus 3. The good news is here, it's actually in slope-intercept form for me. So I'm going to go ahead and plot my y-intercept at -3. I see my slope is 1/2. That's telling me up 1 over 2, up 1 over 2. Now, at first, you can see that I'm using points, but remember, these points are going to help me make the graph because those aren't the only points. I could actually go, down 1 left, down 1 left 2, and I can get additional points. But again, we're tempted here to say, well, this looks like it's going to be then discrete. But I got to remember, this is just my work that's helping me graph this equation. The actual graph of this equation, as we well know, is the line that looks like this. So now, since we connected that whole thing, we can see that this is actually going to be continuous. But that wasn't all that it asked me to determine. All right, determine if it's a function. So I'm envisioning a vertical line. Does my vertical line ever intersect more than one point? Nope. So this is a function. And what I see in this case is that my domain, which is my left to right, is going to -infinity to +infinity. So it's going to be all real numbers. And that is actually the same as what my range is going to be. So my domain and range will both encompass all real numbers because this keeps on stretching infinitely both directions, left and right, and up and down infinitely. Because this keeps on climbing higher, this keeps on going lower. Now I have to determine, is it 1-to-1, on-to, both or neither? I could see that every x value will only have one y value. This is a scenario where we could have an x has two different y's, All right, so that doesn't happen. Every single x in the domain has one y, and every y has exactly one x. So this is actually going to result in a scenario that is both. It is both one-to-one and onto. And as we stated before at the beginning, we know that it's continuous because it's actually covering the entire spectrum because we're graphing an equation and there's an infinite amount of points that satisfy that equation.